Deltamax performance modifiers were created to help converters enhance the performance of recycled polypropylene, helping them to contribute to the circular economy. Converters use recycled polypropylene in combination with virgin resin for a better result while still optimizing cost. With Deltamax performance modifiers, however, the physical properties of recycled polypropylene are boosted, making it equal to or better than those of virgin resin. This enables converters to achieve higher performing blends or make parts with 100% recovered plastic, which promotes a circular economy and reduces plastic waste. Use more recycled polypropylene with Deltamax Performance Modifiers by Milliken.
Hello everyone, I'm Brendan Lafferty, Vice President at Crane Communications and publisher of Sustainable Plastics and Plastics News. A warm welcome to the PRSE virtual event. Today, you've joined us for Ask the Expert, our live stream series featuring the latest technology for the plastics recycling market. In this session, Ask the Expert will explore enhancing the properties of recycled polypropylene resins in injection molding. And our experts today are from Milliken. They are Tucci Asici Van Houset, Senior New Business Development Manager, Plastic Additives, and Marta Sanz Pena, Technical Service and Development Engineer, Plastic Additives. They will answer questions after their presentation. If you would like to submit a question to our speakers, please email prse@crane.com at any time. Now, let's turn the discussion over to our experts from Milliken. Take it away, ladies.
Thank you, Brennan. Thanks for the nice introduction. And hi, everyone. Thanks for joining us this Friday afternoon. We hope that everybody is healthy and safe and had a good conference so far. And thank you really so very much for choosing to focus the next 30 minutes on learning about Deltamax technology. So with that, we can start our presentation. And in the next slide, I will cover what will we talk about this afternoon. So first, I will set the scene by going through the drivers that shape our market in Europe. And we will take a look at the available polypropylene resins in our market. And we will dive into the challenges, especially the impact performance challenges of post-consumer recycled PP resins. And then Marta will show you how Deltamax technology provides opportunities to overcome some of these challenges. And then after that, I will conclude by showing you two case studies that demonstrates how we add value to our customers using Deltamax technology. But first, in the next slide, we will take a look at what we would like you to remember after our presentation. So Deltamax technology is designed for injection molding of polypropylene resins. This also includes the recycled resins, of course. Through improved melt flow, Deltamax enables you to lower injection molding temperatures, so lower energy and carbon emissions. It also allows you to increase recycled content through optimizing the physical performances. And as a third benefit, it reduces complexity and it provides you formulation flexibility. So let's now take a look at the market challenges that we are facing in the next slide. And the next slide, please. So, of course, all of us have been seeing images very similar to these time after time again. So as the plastics value chain, we are all working very hard on changing this unintended consequence, really, for the better. So that's why we are here. That's why we've spent also the last 3 days looking at opportunities to overcome some of these challenges. So recycling infrastructures and technologies that enable increased use of polypropylene, increased use of recycled content, really are key parts of the solution. In the next slide, you will see that maybe some of you know already, back in October this year, the Global Commitment 2020 Progress Report was published. So Ellen MacArthur Foundation's New Plastics Economy along with the UN Environment Agency, come together and publish this progress report. It's an annual report, and this year the second one was published. So in this report, there are 118 companies who produce, use, and recycle large volumes of plastic packaging, and also 17 different governments across 5 continents. They provide data to show how they are progressing versus the targets. So these companies have all been publicly announced that they will increase the post-consumer recycled content in their packaging. And currently we see that they are collectively at 6.2% versus the target of 25%. Of course, there is a lot of focus on improving the quality of recycled plastics that are available in the market. Also, of course, the legislators are acting very, very fast. There is a lot of activity happening at the EU Commission level, but also at the member states level. There's a large focus on policies that improve the economics for recycling and also create markets for recycled content. Several countries like Italy, Spain, and the UK have already announced they will implement the so-called plastic tax starting next year. And it's also expected that many other member states will do similar things. They will implement similar tactics that benefit more and more recycled resin usage. So in the next slide, we will see how specifically the polypropylene market will achieve these targets. So as you can see on this pie chart, the end users are rigid polypropylene are very diverse. And that means they all have their own performance criteria to come with. Most injection molded applications of polypropylene, they use ICP, so impact copolymers, or these products are also called the block copolymers or heterophasic copolymers. So these type of products enable injection molders, converters to reach these performance targets. So let me show you how it looks like when we plot the virgin resins on this chart. On the left-hand side, you can see the impact performance, so the notch Sharpie performance. That's the y-axis. On the x-axis, you see the melt flow, which is a proxy for the processability. So you see in dark blue the virgin ICP resins, and you can clearly see here that there is a trade-off between high impact performance and high melt flow. Most of the non-food applications of ICPs in injection molding, they require at least a medium impact performance. And here, this is depicted with the red line. We put that at about 8 kilojoule per square meter, not Sharpie value. And now you can see the PCR, so the post-consumer recycled polypropylene resins that are available. And this is where the challenge is coming. So most of the PCR that is unmodified, that is available in the market, the melt flow is about 10 grams per 10 minutes, and the impact performance, so the not Sharpie impact performance is about 5 kilojoules per square meters, which is below the red line. So it is a critical challenge that we need to overcome, we're looking to overcome, that will enable the increased use of post-consumer recycled polypropylene in injection molding. So now that we've covered the impact-related challenge of the PCR, I will give the word to Marta, and she will tell us about the opportunities that Deltamax technology can help us on how to overcome these.
Thank you, Tuğçe, and hello, everyone. I will take the next minutes to show how industry is currently addressing the challenge of post-consumer recycled polypropylene and issues around impact. And I will also show how Deltamax new Milliken technology can effectively address that and expand the toolbox. If we go to the next slide, we will see how customers are trying to overcome these shortcomings with two different tactics. The first one is blending virgin impact copolymers with recycled polypropylene. And the second one is using impact modifiers to basically boost that impact of the recycled polypropylene. I'll start in next slide looking into blending virgin ICP with recycled polypropylene. In this particular case, a customer was using a virgin impact copolymer with a good balance of flow and impact performance. On the left-hand side, y-axis, we can see Norwich Sharpie impact in kilojoules per square meter. On the right y-axis, it's melt flow rate in grams per 10 minutes. That particular resin being used is 12.5 Sharpie and at around 25 MFR. This grade was chosen because of the good flow, which allows for fast cycle through early demolding, as well as because of its impact. The application is buckets and pails, which requires quite some level of impact performance in the final application. As many other customers, that particular customer had a target in recycle use and was looking for a PCR stream to be able to produce the buckets. The PCR at hand is the one we can see on the second bar here. It has a good flow, MFR 29, slightly better than the incumbent impact copolymer. When it comes to Sharpie, it's 5.1 versus 12.5, so significantly lower than the qualified material. This is, of course, a challenge and doesn't allow the one-to-one replacement of virgin ICP with post-consumer recycle. One of the things industry does, and I've mentioned that before, is blending virgin with post-consumer recycle. In this particular case, a blend of 70% virgin impact copolymer with 30% post-consumer recycle was evaluated. We see here on the third data point in the graph, this material keeps a good flow, MFR of 29, and there is a significant increase in impact. This blend achieves a 9.8 knot Sharpie, which is significantly higher than the 100% PCR, but there is still a gap when we compare it to the reference impact copolymer. This is still a challenge and it needs overcoming as we cannot meet the final application requirements. And here is what I would like to introduce, how DeltaMax can effectively help fix that challenge. So the last bar in the graph, that's the impact resistance of the 70 ICP, 30% post-consumer recycle blend, plus 1% DeltaMax i300. Here we can see how the flow is maintained at the same level as the other samples and slightly higher than the reference impact copolymer. And when it comes to impact, there is a significant increase in Sharpie versus the 70%, 30% blend. So one can achieve a 12.3 Sharpie, which is comparable to the qualified virgin ICP that has been used so far to produce those buckets. So that means that 1% DeltaMax i300 allows up to 30% recycled polypropylene use in that formulation to produce the buckets without having to trade off neither on processability, fast cycles, nor on impact performance of the final parts. Well, I would like to go to the next slides and let me ask you if you've been pressed to increase even further your PCR content. Here I would like to show the second tactic used by the industry, which is impact modification use. This is another example using another PCR, fairly typical characteristics of a PCR, a Sharpie of a 5.2 and an MFR 13. That particular customer was looking for expanding into the market, looking into other applications. The limitations here are flow and impact when trying to access more demanding applications. It's commonly used in the industry, the impact modification. Specifically here, I'll focus on polyolefin elastomers. Typically, high amounts of additives are required to make a sustainable or a significant step change in impact performance. This has also some drawbacks, especially in flow decreases, and stiffness also reduces significantly. To overcome that, industry is using peroxides, and that's the second sample in orange that we see on the graph here on the screen. So 7% polyolefin elastomer plus peroxide does bring that flow improvement. We can boost that flow from 13 to 29. When it comes to impact, we see slight increase from 5.2 to 5.6, which is not really significant to access some of the more demanding impact applications. Here in this study, we stayed below the 10% non-PCR content. As we see, this is a requirement through the value chain to stay below that amount of non-PCR in the final formulation. Next, I would like to show how Delta Max can effectively boost both flow and impact with just a small addition into the formulation. So the third sample you see on the graph in purple, that's the notch Sharpie of a 7% polyolefin elastomer modified with 1% Delta Max A200. Here the flow we can reach is even higher than with peroxide, MFR 35, and the impact notch Sharpie is increased with 3 units from 5.2 of the starting PCR to 8.3 when using Delta Max A200. With I300, we can even improve the impact further, and we can get to a 9.1 notch Sharpie value, which is 4 units higher than the initial PCR, while also achieving a very good flow as we can get to a 24 MFR. So Delta Max A200, Delta Max I300 in combination of polyolefin elastomer allow to boost that impact in the formulation and bring the properties of your PCR to a next level, not only in flow as well as in impact performance. We can go to the next slide, please. You've heard me say Delta Max A200, Delta Max I300. I would like to tell you more about the product range of Delta Max technology at Milliken. In the next slide, you will be able to see how Delta Max have achieved the best possible balance in properties between impact, stiffness, and malflow rate. There are 3 pre-formulated master batches available to be able to work on that property balance. M100 is the malflow modifier, which improves the flow in a way that allows for faster cycles, earlier demolding, and less energy consumption, and at the same time maintain that mechanical performance and not compromising on impact. The second product range, or second product in the product range, is Delta Max A200 all-purpose modifier, which is a combination and works in both impact and malflow rate. And the third one is the impact enhancer, which really maximizes the impact performance of your ICP without compromising in flow, and that's Delta Max I300. Depending on the challenge converters or compounders have, there is a choice between these 3 pre-formulated products, and basically what Delta Max provides here is a flexibility by allowing the use of one same ICP and modifying these properties for using this one material into a wide range of parts and by achieving different types of property balances. You may be wondering how Delta Max can be used and where it can be added. In the next slide, we can see that it can be added in injection molding machines, as well as in compounding lines, single screw and twin screw. It basically can be added as any color master batch, dry blends or tumble blends. If there is an available feeder in your machine, it can also be added by the throat of that machine. To achieve your Delta Max solution, you can use virgin ICPs, PCR blends, And typically, we recommend dosing Delta Max master batches between 0.5 and 1% into that composition. That was my last slide. In the last few minutes, I've covered how Delta Max can help you improve the properties of your post-consumer recycled polypropylene, help you boost that impact to be able to either increase the amount of post-consumer recycle in the formulation or boost that impact to be able to target a different expand of applications by improving that performance. I'll now give the word back to Tuche, who will guide you through the rest of the presentation.
Thank you, Marta, for showing us the possibilities that Delta Max product line brings and how to use it easily. So in the next and final section of our presentation, I will show you 2 case studies and I will demonstrate where we created value for our customers. In the next slide is our first success story, and the hero in the success story is our customer who are injection molding a wide variety of housewares parts. This customer is already able to actually produce some of their products using 100% recycled polypropylene. But for other parts, which are more thinner walled, etc., that the melt flow is really the limiting factor for them. They would need an increased melt flow and not to let go of the impact performance to be able to achieve that. So to overcome that, what they were trying to do is, as Marta explained, is that they were adding a higher melt flow resin, a virgin ICP resin. And through the high melt flow of this heterophasic copolymer, they were able to get about only 30% recycled content in their bigger parts. So what we could do for them is throughout the Delta Max M100, a few minutes ago, Marta showed us that through the Delta Max master batches, we can significantly increase the melt flow without destroying the impact. So they were successfully able to use the M100 master batch from Delta Max series, and through the melt flow increase, they were able to mold easily 100% recycled resins for these more challenging parts. So they were able to achieve their goals faster, and as an added benefit, really, they were enjoying the reduced complexity in their operations. In the second case study, in the next slide, we have our success story with a customer who manufactures a variety of different plant pots in also various colors. They also, of course, are very much looking into keeping a good cost position. So they are running highly optimized operations. They're using higher melt flow resins. They are keeping an eye on their cycle time and energy use. But the challenge they were facing is then to further reduce the energy consumption, to further reduce the carbon emission as part of also going further into their sustainability goals. So what we did, we were supporting them in running an energy reduction trial. So they used a data logger on their injection molding machine. And this equipment enabled them to log the specific energy that is used during injection molding. So first they did this by to establish the benchmark just in their standard operations at that part. And afterwards, they added the Delta Max A200 at the machine side through the feeder, and then optimized the settings once more. So through the addition of Delta Max A200, we were able to further reduce their energy consumption by 12%, which meant directly, of course, 12% energy reduction, and had a good boost in their sustainability performance. As an added benefit, they were able to increase throughput by further reducing their cycle time. And of course, this had the benefit of also reducing their overall cost performance as well. So in the next slide, just to summarize, hopefully we have been able to show you some valuable and relevant insights, and you have some now ideas on how to make use of the DeltaMax technology for improving the performance characteristics of your polypropylene resins. So in the next slide, you will see our experts in the other regions as well. So please contact us. Let's talk and let's see how we can support you in achieving your sustainability goals faster. Thank you.
Great presentation, Tucci and Marta. Hopefully you're ready for some questions now. To our audience, if you would like to submit a question to our speakers, please email prse@crane.com and we'll get the questions to our speakers. All right, guys, first question. Are these products food contact approved?
Let me take that one, Brennan. So we get a lot of this question, as you can imagine. So the three master batches that Marta took us through, the melt flow modifier, all-purpose modifier, and the impact enhancer, they are currently not food contact approved. But I am happy to say that, of course, we are working on new products in the product range. So currently not available, but hopefully watch this space.
There you go. Coming soon. How about stiffness and flex, especially when POE is used? This is a major challenge, is it not?
Yeah, in general, we observe an average of a 10% stiffness reduction measured on the flex modulus. This is normally seen as acceptable by the customers, this 10% decrease. The DeltaMax example with polyolefin elastomer, yeah, there indeed what DeltaMax does, it allows to achieve a high impact with a smaller addition of polyolefin elastomer, which helps get best higher stiffness out of the total system compared to when only polyolefin elastomer has to be used in very high amounts to get that impact boost. So in overall, yeah, we see some reduction in stiffness when used DeltaMax, but it's typically seen as something acceptable.
Now you showed two DeltaMax products increasing impact further without the addition of impact modifier. Why does it not work for PCR?
So that's another great question. Another question we get very frequently, of course, and we all wish it did, right? That would have been great if we could create impact pretty much out of nothing. So the DeltaMax technology, our products make use of the rubber that is already in the system. So it's either in the resin or in the blend. If there is enough rubber in the system, we are able to boost it further. So most of the time in the post-consumer recycled resins, it's a mixture of homopolymers, a little bit of random, a lot of household waste that we have in our daily life. So we see that kind of the threshold is around that 8 kilojoule per square meter, not Sharpie impact. So if there is already a performance in the starting point around 8 kilojoules, we are able to boost it further. But most of the PCR resins, they're already starting at around 5. So we need that additional rubber to be able to make use of it. And then have a unique boost to that. So that is the reason for PCR that most of the time the polyolefin elastomer is introduced.
Okay.
Hope that answers the question.
Yeah, for sure. So another question, PCR resins can be mixed with PO streams. Does it work for polyethylene streams?
Since our products, our DeltaMax master batches are made of peroxide, we recommend to limit the amount of polyethylene in the PCR stream. And as a guideline, as an indication, we recommend that there is a maximum of 10% of polyethylene in the PCR.
does it affect the shelf life of the part?
It should not. I mean, we wouldn't expect it to affect the shelf life. So based on kind of the multi-pass studies and etc. that we have done, and the successful customers that are using it already for a longer time, we would not expect to have any negative impact on the shelf life.
Oh, good news. Very good. Well, ladies, I believe that's all the time we have for questions today. On behalf of PRSE, thank you to Tucci and Marta for your time and expertise.
Thank you. Pleasure being here.
If you have additional questions for Tucci and Marta, please use the email address on the screen to reach out to them. Any questions submitted that were not answered today will be passed to our speakers, who will be happy to answer them. My thanks to Milliken and our speakers Tucci Asici van Housit and Marta Sanz Peña for joining us today. I would also like to thank you, our audience, for attending Ask the Expert. Don't forget, you can connect with our exhibitors and sponsors through Conversation Starter, our PRSE networking software, which is found on our PRSE event website.
Deltamax performance modifiers were created to help converters enhance the performance of recycled polypropylene, helping them to contribute to the circular economy. Converters use recycled polypropylene in combination with virgin resin for a better result while still optimizing cost. With Deltamax performance modifiers, however, the physical properties of recycled polypropylene are boosted, making it equal to or better than those of virgin resin. This enables converters to achieve higher performing blends or make parts with 100% recovered plastic, which promotes a circular economy and reduces plastic waste. Use more recycled polypropylene with Deltamax performance modifiers by Milliken.